Hello everyone, welcome back to my channel. So let's start with question number 5. We need to find the value of k for which the following equation has two distinct roots. So first of all, if the equation is ax square plus bx plus c is equal to 0. So for distinct root, the discriminant should be greater than 0. So discriminant is b square minus 4ac and the value of discriminant should be greater than 0. So this is the condition for two distinct roots. Now let's first of all simplify this equation, bring this value of k to the left hand side. So we get x square plus 8x plus of 3 minus k is equal to 0. Now let's compare it with the general equation ax square plus bx plus c is equal to 0. So we get a is equal to 1, b is equal to 8 and c is equal to 3 minus k, right? So these are the values of a, b and c. Now if I compare and find the value of discriminant, what I get is b square minus 4ac, that is equal to square of 8 minus 4 times a, which is 1, and c, which is 3 minus of k, right? So if I simplify it, what I get, 64 minus of 4, that is we'll multiply it with 3 minus of k, we get 4 and 3 minus k. So if we simplify it, we get 64 minus of 12 and plus of 4k. This should be greater than 0, right? So what I can do is I can write it as 64 minus 12, that is 52, plus 4k should be greater than 0. So I get 4k should be greater than minus 52, right? Now k should be greater than negative of 13. 52 divided by 4 is 13. So k should be greater than negative 13. I hope it is clear. So this is the result, and the value of k should be greater than negative 13. So for all the values of k greater than negative 13, the discriminant will be greater than 0. That means we will have two distinct roots. I hope it is clear. Let's move forward. First of all, let's bring everything to the left hand side. We get 2x square minus 5x minus of 4 plus of k is equal to 0. Right? If I compare it with the general equation ax square plus bx plus c is equal to 0, what I get is a is equal to 2, b is equal to minus 5, c is equal to minus 4 plus of k. Right? Now I will find the value of discriminant, that is b square minus 4ac. So it is equal to minus 5 square minus 4 times 2 times negative 4 plus of k. So I get 25 and minus 8 minus 4 plus of k. It is 25 plus of 32 and minus of 8k is now this is equal to 25 plus 32, it is 57 minus 8k. Now for getting two distinct roots, the discriminant should be greater than 0. So b square minus 4ac should be greater than 0. It means 57 minus 8k should be greater than 0. So what I get is negative 8k is greater than negative 57. Right? So we cancel these negative outs. So the sign of this inequality changes. So what we get is 8k is less than 57. K is less than 57 by 8. Right? So this is what we are getting, and this is the value for k. So for all the values of k which are less than 57 by 8, we get two distinct real roots. I hope it is clear. Let's move forward. Comparing it with the journal equation ax square plus bx plus c is equal to 0, we get a is equal to k, b is equal to -4, and c is equal to 2. We find the value of discriminant, that is b square minus 4ac, that is equal to now -4 square b square minus of 4 times a, that is k, and times c, that is 2, right? So we get now square of 4 is 16 minus of 8k. To get two distinct real roots, b square minus 4ac should be greater than 0. It means 16 minus 8k should be greater than 0. This implies that negative 8k should be greater than negative 16. 8k is less than 16. K is less than 2. So this is the value for k. So for all the values of k which is less than 2, we get distinct real roots for this equation. I hope it is clear. We have this equation. We'll compare it with the journal equation ax square plus bx plus c is equal to 0. So from here, a is equal to k, b is equal to 2 times k minus of 1, and c is equal to k, right? Finding the value of discriminant b square minus 4ac, so this is equal to negative 2 k minus of 1 whole square b square minus 4 times a, that is k, and c, that is also k, right? So if I open this, I get 4 k square plus 1 minus 2k minus 4k square. So if I open up this equation, we get 4k square plus of 4 minus 8k minus 4k square. This 4k square gets cancelled out. What I get is 4 minus 8k, right? For getting two distinct real roots, what I get is b square minus 4ac should be greater than 0. So I get 4 minus 8k, that is the value of b square minus 4ac, should be greater than 0. Negative 8k is greater than negative of 4. 8k is less than 4. So whenever I multiply both sides of inequality with a negative, the sign of inequality changes. K is less than 4 by 8. K is less than 1 by 2, right? So for all the values of k less than half, we get a distinct real root for this equation. Let's move forward. Alright, let's simplify it first of all and bring everything to the left hand side. We get kx square minus 2x plus 2 minus k is equal to 0, right? If I compare it with the journal equation ax square plus bx plus c is equal to 0, I get a is equal to 2, b is equal to -2, c is equal to 2 minus of k. Alright, so a is 2, b is -2, c is 2 minus of k. Finding the value of discriminant b square minus 4ac, that is equal to -2 square minus of 4 times a, that is 2, and c, that is 2 minus of k. Simplifying it, we get 4 minus of 8 times 2 minus of k. So what we get over here is 4 minus 16 and plus of 8k, right? So we get negative of 12 plus 8k. So we get two distinct real roots whenever the discriminant is greater than 0. That means b square minus 4ac should be greater than 0, And the value of b square minus 4ac is negative 12 plus 8k. So negative 12 plus 8k should be greater than 0. This makes 8k greater than 12 and k greater than, we get 3 by 2. So this is our answer. So for all the values of k greater than 3 by 2, we'll get two distinct real roots for the quadratic equation. Alright, next part is this. Let's simplify it, bring everything to the left hand side. We get kx square plus 2k minus 5x, and we get plus of k minus 1 is equal to 0. Comparing it with the journal equation ax square plus bx plus c is equal to 0, we get a is equal to k, b is equal to 2k minus of 5, c is equal to k minus of 1, right? So I'll find the value of discriminant b square minus 4ac. So b square minus 4ac is equal to square of b, that is 2k minus 5, and minus 4. So a, that is k, and c, k minus of 1, right? So squaring it, what I get is 4k square plus 25 minus of 20k and minus of 4k square plus 4k, right? So if I open it up, 4k square minus 4k square minus 20k plus 4k plus of 25, it is equal to negative 16k plus 25, right? So the value of discriminant should be greater than 0 for two distinct real roots. So what I get is negative 16k plus of 25 should be greater than 0. It means value of k will be 16, negative 16k should be greater than negative 25. So multiplying both sides with negative, we get 16k is less than 25. We get k is less than 25 by 16. So this is our result. I hope it is clear. Let's move forward. Find the value of k for which the following equations have no real roots. Okay. So we need to find the value of k for which the equation has no real roots. So no real roots means the discriminant b square minus 4ac should be less than 0. No real roots. If we have b square minus 4ac is equal to 0, this will give us two equal real roots. But no real root means the number should be, discriminant should be less than 0. It means comparing it with journal equation ax square plus bx plus c is equal to 0, we get a is equal to k, b is equal to negative 4, c is equal to 8, right? So discriminant b square minus 4ac is equal to negative 4 square minus 4 times k times 8, right? Simplifying it, we get 16 and minus of 32k. So b square minus 4ac should be less than 0 for no real roots. So we write it as 16 minus 32k should be less than 0, right? And we get 32, negative 32k is less than negative 16. Multiplying both sides with negative, we get 32k should be greater than 16. K is greater than 16 by 32. So if we divide it by 16, we get k is greater than 1 by 2. So we get k is greater than half. I hope it is clear. Let's move forward. Comparing it with journal equation ax square plus bx plus c is equal to 0, we get a is equal to 3, b is equal to 5, c is equal to k plus of 1. Alright, value of a, b and c. Now Finding the value of discriminant b square minus 4ac, what we get is square of 5 minus of 4 times a, that is 3, and c, that is k plus of 1. So if we simplify it, square of b, so square of 5, 25 minus 4 3 is 12 times k plus of 1. So it is 25 minus 12k minus of 12. So this is the value of b square minus 4ac, and b square minus 4ac should be less than 0 for no real root. It means 25, and 25 minus 12, this is equal to 13. So we can write 13 minus 12k should be less than 0. So from here we can write it as negative 12k is less than negative 13. 12k is greater than 13. K is greater than 13 by 12. Right? Multiplying negative changes is sign of inequality. We get k is greater than 13 by 12. I hope it is clear. Let's move forward. So comparing, first of all, simplifying it, bringing everything to the left hand side, we get 2x square minus kx square and plus 8x minus 5 is equal to 0. So we take x square common, we get 2 minus k x square plus 8x minus 5 is equal to 0. Right? Comparing this with general equation ax square plus bx plus c is equal to 0, we get a is equal to 2 minus k, b is equal to 8, c is equal to minus 5. So finding the value of discriminant b square minus 4ac, which is equal to square of 8 minus 4 2 minus of k, and c, that is negative of 5. We get square of 8 is 64 plus of 20 2 minus of k, and that is equal to 64 plus of 40 minus of 20k is equal to 104 minus 20k. So value of b square minus 4ac should be less than 0. It means 104 minus 20k should be less than 0. That is 20k is less than negative 104. K 20k is greater than 104. K is greater than 104 by 20. That is k is greater than 26 by 5. I hope it is clear. Let's move forward. Let's bring this to the left hand side. We get 2x square minus 3x and plus of k minus of 6, plus of 6 actually, is equal to 0. Comparing it with general equation ax square plus bx plus c is equal to 0, we get a is equal to, b is equal to negative 3, and c is equal to k plus of 6. Right? So these are the values of a, b, and c. You will find the value of discriminant b square minus of 4ac. So b square minus 4ac is equal to negative 3 square minus 4 times a, that is 2, and c, that is k plus of 6. We get 9 minus 8 k plus of 6. 9 minus 8k minus 8 6 of 48. So this is the value of discriminant. We'll simplify it. We get negative of 39 minus 8k. b square minus 4ac should be less than 0 for no real roots. So we get negative 39 minus 8k is less than 0. So from here what we get is negative 8k is less than 39. 8k is greater than negative 39. K is greater than negative 39 by 8. So this is our result for k. So for all the values of k which is greater than negative 39 by 8, we get the value of discriminant less than 0. It means we have no real root. Alright, let's simplify it. We get kx square plus 2kx minus 4x plus of 6 is equal to 0. So kx square, and if we take x common, we get 2k minus of 4 and x plus of 6 is equal to 0. So from here, if we compare with the general equation ax square plus bx plus c is equal to 0, we get a is equal to k, b is equal to 2k minus 4, and c is equal to 6. Right? So if I find the value of discriminant b square minus 4ac, what I get is 2k minus of 4 minus of 4 times a, that is k, and c, that is 6. So what I get, squaring this, so we get 4k square plus of 16 minus 2 fours are 8 into 2, that is 16k, and minus 6 fours are 24k. So if I simplify it, I get 4k square and negative of 40k plus of 16. So this value should be less than 0. So we can write it as 4k square minus 40k plus of 16 should be less than 0. I can take 4 common from here. I can write it as k square minus 10k plus of 4 should be less than 0. So product over here is of 4 and sum is negative 10. So to simplify it, what I will do is, first of all, I will find the values of the roots for this quadratic equation. So I will apply the quadratic formula over here. So value of k is negative b plus minus root of b square minus 4ac divided by 2a. So it will give me negative of negative 10 plus minus root of negative 10 square minus 4, a is 1 and c is 4, divided by 2a, that is 2. So what I get is 10 plus minus root of 100 minus of 16 by 2. So I get 10 plus minus root of 84 by 2. So these are the two values of k. So I get k is less than 5 plus minus. So I can take 4 common from here. What I can write it as 10 plus minus 2 root of 21 by 2, that is equal to 5 plus minus root of 21, right? So k is actually less than 5 plus of 21 and greater than 5 minus of root of 21. So these are the values of k. Okay, let's simplify it. We get kx square plus kx minus 3x plus of 2 is equal to 0. So if we simplify it a bit, kx square plus k minus 3x plus 2 is equal to 0. If I compare it with the general equation, ax square plus bx plus c is equal to 0, what I get is a is equal to k, b is equal to k minus of 3, c is equal to 2, right? Finding the value of discriminant b square minus 4ac, what I get is k minus 3 whole square minus of 4, a is k and c is 2. So if I open this whole square, I get k square and plus of 9 minus 6k minus 8k. So I get k square plus 9 minus of 14k. So again, finding the values of k. So for that, what I will do is I will take b square minus 4ac is less than 0, right? So first of all, I will simplify this quadratic equation. K square minus 14k plus of 9 is equal to 0. I can find the value of k by quadratic formula. K is equal to 14 plus minus root of square of 14. So that is 196 minus 4. A is 1 and C is 9 divided by 2 times 1. 14 plus minus root of 9 fours 36, and if we subtract 36 from here we get 160 by 2. So I can take 4 out from this under root. What I will get is 14 plus minus 2, 40 by 2. I can again take 4 out, so it becomes 14 plus minus 4 root of 10 by 2. I can divide this by 2, so 7 plus minus 2 root of 10. So the range is when k is less than 7 plus 2 root of 10 and k is greater than 7 minus 2 root of 10. These are the values of k. I hope it is clear, and we'll do next question in the next class. Till then, take care.